Okay, so this is the integration and differentiation test. First thing, find the integral of sine 2x plus e to the 4x. So what we're going to do is we're going to go to our tables, okay, and we're going to find out what happens when you integrate sine. When you integrate sine, you get minus cos. So when you integrate sine, you get minus cos, okay. So what we're going to get is minus sine 2x. Oh, sorry. When you integrate sine, you get minus cos. So there is there, minus cos. So what we're going to get is minus cos 2x. The angle never changes. Now, what happens here is that we got to remember that you usually differentiate by this when you differentiate. So we're going to have to differentiate the angle, which is 2. And when we do that, it's going to be minus a half. So we're going to divide it by 2. We're going to divide it by the derivative of the angle. Okay, so when we were to differentiate this, it will turn back directly into sine 2x. Now, the rule for e is that e always maintains its power, so it's going to be e to the 4x. Once again, we're going to differentiate the power and divide it by that, so it's going to be 1 over 4 e to the 4x. Okay, so 1 over 4 e to the 4x, and it's an indefinite integral, so it's going to be plus c. That's the answer to the first one. Now part 2, the curve 12x cubed minus 48x squared plus 36x crosses the x-axis of 0, 1 and 3 as shown. Calculate the total area of the region enclosed by the curve on the x-axis. So what's going to be is going to be integral from 0 to 1 gives us area A, so that's going to be 1, 0, 12x cubed minus 48x squared plus 36x plus the integral of this red region here that we'll call B, the integral of 1 to 3. So we'll just do it one at a time. So this integral of 1 to 3, 12x cubed minus 48x squared plus 36x. Now let's integrate. So when we integrate, what we're going to get here is we're going to add 1 onto the power, x over 4. Now what happens is we're going to divide the old power by we're going to divide the coefficient by 4. So we're going to get 3x4 for the first one. We're going to get x3 for the second one. We're going to divide 48 by 3. We're going to get minus 16x3. Then we're going to get x2 for the third one. And we're going to divide the 36 by the new power, which is going to be 18x squared. That's what happens when you integrate them. And now it's from 1 to 0. Now to do this from 1 to 0, what we need to realize is that it's going to be 3 times 1 to the power 4 minus 16 times 1 to the power 3 plus 18 times 1 to the power 2. Now it's going to be minus all zeros in the other one because it's going to be 3 times 0 to the power 4 minus 6 times 0 to the power 3 plus 18 by 0 to the power 2. So basically that doesn't count because they're all zeros. Okay, so once we're aware of that, we just put it in, and what we're going to get is 3 minus 16 plus 18, and what that's going to get me is 5. Area A is 5. Now we can rub this out here, and now I'm going to start on the second one for area B. Now area B has the same integration as area A, just different limits. So remember, it's the upper limit, so it's 3 to 1. So 3 to 1. So we're going to put it in here, so it's going to be 3 times 3 to the power 4 minus 16 times 3 to the power 3 plus 18 times 3 to the power 2 minus brackets 18 times 1 to the power 4 minus 16 times 1 to the power 3 plus 18 times 1 to the power 2. Now we already know that this here is 5 from earlier, and what we're going to get for this one here is basically 3 to the power 5 minus 16 times 3 cubed plus 18 times 3 squared, and what we get is that there is going to be actually minus 27. So it's going to be minus 27. Oh, sorry, one mistake there. I didn't put that as it. That's a 3. So it's minus 27 minus 5, which gives me an area of minus 32. Now this area of minus 32, the minus simply represents that it's below the x-axis as minus 32. However, areas are considered positive, so it's going to be plus 32. 32 plus 5 gives us a region of 37. Area equals 37. Okay, so now we're on the next one. Okay, so this 2014 sample, we're going to use the quotient rule. So du dx equals 1. dv dx equals, once again, when you look at the ln x, the integral, or we're looking for differentiation now, excuse me. So when you differentiate ln x, you get 1 over x. Okay, so equals 1 over x. U equals x. V equals ln x. Now, we have to find the first derivative. So hx is going to be u times dv dx plus v times du dx, being the product rule. So 1 times 1 over x plus v, which is ln x, multiplied by 1. So we're going to get 1 plus ln x. Now, next thing we're asked to do after that is hence find the integral of ln x dx. Okay, so if you imagine that dy dx, or the first derivative, is what we just got here a second ago. First derivative equals 1 plus ln x. dy therefore equals 1 plus ln x dx. Now we multiply this out as if we're multiplying out a regular, what's the word? A regular multiplication, okay? And then that's dy. What we're going to do is we're going to integrate both sides. Integral, integral, integral. Okay? That's going to be 1 dx, 1 dy. Now, the whole point of the question is to find out what is the integral of ln x dx. ln x dx being this part here. Okay? So once we do that, what's going to happen next is we're going to integrate it. When you integrate 1 dy, you get y. When you integrate 1 dx, you get x. And then you get ln x dx, the integral of ln x dx. Now remember, it's an indefinite integral, so there's going to be a constant at the end. So we're going to change y. We know that y equals the original function. Y equals x ln x, because it's the original function. So x ln x, take away x, equals the function of and ln x dx. Now all we have to do next is, we forgot about the c value because there's no limits on these integrals, so it's going to be x ln x minus x plus c, and that's the integral of ln x dx. Okay, now we're going to move on to the next question. Differentiate x squared from first principles. So first principles means that f of x equals x squared. Now we know the answer is 2x, but we've got to work there. F of x plus h ends up to be x plus h to be squared, which ends up to be x squared plus 2hx plus x squared. Step 2 then is f of x plus h minus f of x, and this turns out to be x squared plus 2hx. Oh wait, that's a h squared, excuse me, plus h squared minus x squared. Two of them cancel, and we're going to be left with 2hx plus h squared. Third part is going to be f of x plus h minus f of x all over h, which is going to be our 2hx plus h squared all over h, and what we get is 2x plus h. Part 4 is the limit as h approaches 0 of f of x plus h minus f of x all over h, which is then going to be our 2x plus 0, because this h here turns to 0. Okay, so the answer is 2x as expected. Okay, next question. The next question is let y equal cos x plus sin x, and then over cos x minus sin x. Find the first derivative. Well, we have a quotient rule, where the quotient rule is equal to phi times du dx minus u times dv dx all over phi squared. Okay, so what we're going to get is u equals cos x minus sin x. Now remember, when you differentiate cos x, you get minus sine x, and when you differentiate sine x, you get plus cos x. So once again, du dx, this is going to turn into minus sine x, and the sine x changes directly into cos x. Directly into cos x. So you get minus sine x cos x for du dx. V equals, that should be a plus cos x, because it's u. V is cos x minus sine x. Therefore, dv dx is going to be minus sine x minus cos x. Okay. Next thing we're going to do is apply the quotient rule. So we're going to have dy dx ends up to be phi times du dx. So it's going to be cos x minus sine x multiplied by du dx, which is minus sine x plus cos x, and then minus u times dv dx. So u is cos x plus sine x, and dv dx is minus sine x minus cos x all over. So the thing to remember about this dv dx is this dv dx is minus 1 by sine x plus cos x. So I can modify this here. So there's a minus 1 here, and there's going to be a minus 1 here, and I'm just going to change that to minus 1 sine x plus cos x. Minus 1 times sine x plus cos x. Now, if you have minus 1 multiplied by, let's say, 5, multiplied by another minus 1, the two minus 1's can interact to make plus 1. So I'm going to do the same trick here. So what's going to happen is that's going to turn into a plus 1. Excuse me. That's going to turn into a plus 1. And that's going to be just cos x. That's going to be another sine x plus cos x. And it's all going to be over phi squared, which is going to be cos x minus sine x squared. Now, dy dx therefore equals, going to have to multiply this out. We're going to get minus cos x sine x. Then we're going to have plus cos squared x. We're going to have plus sine squared x. Now, sine squared x plus cos squared x. Go to page 13 of your notes, and you can see here cos squared a plus sine squared a equals 1. Okay, so we can change that into a 1. Works for any angle. Okay, so plus 1. And then what we're going to have next is minus sine x by plus cos x is minus cos x sine x. Okay, on the other side, we're going to have cos x by sine x is cos x sine x. We're going to have a cos x by cos x is cos squared x. We're going to have sine x by sine x is plus sine squared x. And once again, that is going to turn into 1. Okay, and then we're going to have plus sine x cos x, or cos x sine x. Okay, now the interesting thing to know here is minus cos x sine x cancels with that one. This one here will cancel with that one there. So this whole top line basically becomes the number 2. Okay, so equals number 2 plus 2, that is, over cos x minus sine x squared. Now, next part is show that dy dx equals 1 plus y squared. Well, we know that dy dx equals this, okay? So what we can do is we can say that dy dx equals 1 plus, now what is y? Y is cos x plus sine x over cos x minus sine x to be squared. Now, squared means square the top and the bottom, which in turn means square this part here and this part here, which in turn means this here, all over cos x minus sine x. Okay, and we're going to try and prove that it's equal to this thing up here. So let's see if we're able to pull this off. Okay, so what we're going to get is 1 Now, we don't have to the bottom doesn't have to be multiplied out. Okay, so it's going to be 1 plus all this is that's still cos x minus sin x squared on the bottom. Might as well keep it similar to the answer. Now we're going to multiply cos x by cos x, cos squared x, cos x by sin x. It's going to be 2 cos x sin x. Okay, and then the other one is going to be plus sin squared x. Now this sin squared x and cos squared x can disappear and turn into 1. Okay, then we're looking at this number 1 over here, and what we can see with this number 1 is that what happens if we give it the same denominator as the other one. So what we're going to say is that equals it's going to equal cos x minus sin x to be squared all over cos x minus sin x to be squared. So we're going to concentrate in on this part here and square it out. So when we square that out, what we're going to get is cos squared x plus 2 cos x sin x. We've already squared this out before. It's basically cos x minus sin x multiplied by cos x minus sin x. And we multiply it out. Plus sin squared x. Once again, the cos squared x and the sin squared x turn into 1. Okay. Oh, and it's going to be a minus 2 cos x sin x, because they're both minus signs here. As you can see, that's a minus there and a minus there, which makes that a minus 2 in the middle. Okay, and that's going to be plus this part here, 1 plus 2 cos x sin x all over cos x minus sin x to be squared. The 2 down cancel. We're going to get 2 over cos x minus sin x squared. So we can prove that dy dx 1 plus y squared. So hence 1 plus y squared equals dy dx. Hence dy dx equals 1 plus y squared. Turns into the same thing. Okay. Okay, so next one. F of x equals 1 plus x ln, like the base is ln, 1 plus x. Now, this is a product rule function, u and v. Show that the curve has no turning point, has a turning point. If it has a turning point, it's dy dx, okay, or the first derivative. So, du dx is the derivative of 1 plus x, which is 1. The derivative of v is this thing here is v, so therefore it's going to be 1. So if we go back, the derivative of ln x is 1 over x, but it's not ln x, it's ln x plus 1, so it's going to be x plus 1 here. And you also have to differentiate what's in the bracket, which is differentiate 1 plus x. When you differentiate your 1 plus x, what you're going to get is 1. Okay, now we're going to do the product rule. F dash x equals u times dv dx, u times dv dx plus v times du dx. So we're going to do that there now in a second. Okay, so u is 1 plus x, dv dx is 1 into x plus 1, and then plus u times dv dx is 1 plus x, or say v times du dx, excuse me. So it's going to be ln 1 plus x, and that's going to be getting multiplied by 1. The 2 then cancel, and our answer is going to be 1 plus ln 1 plus x. Now what we know is that this has to be equal to 0, because the first derivative equals 0 for any turning points, okay? So once we're certain about that, what we're going to do is we're going to say this. We're going to solve this, so it's going to be ln 1 plus x, bring that over to your side, equals minus 1. ln means log to the base e. And remember this, okay? It means 1 plus x equals e to the power minus 1. Remember what logs mean. log 10 to the base 100 equals 2. This means that 100 equals 10 squared. In the same way, if I said log 27 to the base 3 equals 3, this basically means, oh sorry, a better one, sorry, excuse me, log 81 to the base 3. Log 81 to the base 3 equals 4. This means 81 equals this number here, 3 to the power of 4. Okay, and this follows the same logic over here. Now, what we're next going to find out is that e to the power minus 1 is in fact 1 over e. We're then going to bring the 1 over the other side, and we're going to get x equals 1 minus 1 over e. Common denominator, turn that into an e over e, because 170 e over e, and you're going to get e minus 1 all over e. I'm hoping that's what we're looking for. Now, oh, excuse me, it was minus 1. Excuse me, what? So, excuse me, it's actually x equals 1 over e minus 1, which is 1 minus e over e. X equals 1 minus e over e. Okay, so that is what we're looking for here. Now we have to get the y value, yeah. So what we're going to do is we're going to get our x equals 1 minus e over e, and we're then going to put it into the y value. Okay, and I'm going to keep the first derivative here as well. So I also need the first derivative. There it is there. So this is the only two pieces of information I need here, okay? So what we're going to do next is we're going to put the x value into the function to find the y value. So the y value equals 1 plus x ln 1 plus x. And what we know is that the x value is 1 minus e over e. So y equals 1 plus 1 minus e over e, bracket, ln 1 plus 1 minus e over e. Now, solve each part separately. I'm going to turn this number 1 into e over e. Now they have the same denominator, so I'm just looking entirely at this part here. E plus e minus e cancels, so it's just going to be 1 over e. Okay, so this part here turns into 1 over e. Next part after that is the ln part. Once again, I'm going to turn this into e over e. The two of them will cancel, and we're left with ln1. Now, 1 over e ln 1. So that's 1 over e ln 1 over e. Now, what we're going to find out is what is ln 1 over e. Okay, so if you have a calculator, so we have a calculator here, we're going to try ln e. So ln 1 over e. So delete 1 over e. It's just e to the power 1. And what we have here is equal to minus 1. So it's going to be 1 over e multiplied by minus 1, which is minus 1 over e. So that's the y value. So we got a y value of minus 1 over e, and we got the x value of 1 minus e over e. So we've proved our turning point, okay? Now just a quick note for you. That's the same, this part here, the ln 1 over e, was the same thing as ln e to the minus 1. ln e to the minus 1 is minus 1. ln, let's say, e to the power 3. It's the power that's important with this. And the answer to that would be 3. So you can check that out yourself. Just a quick side note to the question when it comes to ln e to the power 3 would be 3. Okay, now we have to do the next one is we know that the first derivative f of x, f dash x equals 1 plus ln 1 plus x. Okay, so that's what the first derivative turned out. So now what we gotta do is the second derivative. Prove whether the turning point is a local minimum or a local maximum. So for a local minimum, for a local maximum, the second derivative is smaller than 0. For a local minimum, the second derivative is bigger than 0. So that's a min, that's a max. Okay, it's the opposite of what you think it'd be. So we're going to do the second derivative and differentiate 1, we get 0. Differentiate ln 1 over x, we get 1 over 1 plus x. Then we differentiate the bracket, which is the 1 plus x. When you differentiate the bracket, you get 1. So it's going to be 1 plus 1 over x. Now, what we have to test next is the x value. We know that x equals 1 minus e over e. So it's going to be equal to 1 over 1 plus x. So it's equal to 1 divided by 1 plus 1 minus e over e. Now, you might be able to just get this done on the calculator very quickly, like just there's a 1 there, 1. Then you can get a plus bracket 1 minus e to the power 1 all over e to the power 1 there, and you get 2.71, which is e, which is greater than 0, so hence it's a local minimum. Alternatively, you could just give them the same denominator. These cancel, and it comes 1 divided by 1 over e. Bring that up, turn it upside down, multiply by e over 1, which equals e. E is the same thing as 2.718 as well. Was it 2.71? 718, so there you go. Greater than 0. Now that one's done. Go to the next question. Express cos 2 theta plus sine 4 theta as the sum of two trigonometric functions. So on page, it's basically like cos A sine B. Cos A sine B, okay? So what we're going to do is we're going to look at our notes here and see the cos A sine B here. I'm just going to take a quick snap of this. Cos A sine B, where is it? There it is, there. Cos A sine B. Okay, then we're going to use that on this here. And what we're going to do is change it like this, okay? So if I multiply both sides by a half, I get 1 cos A cos B, cos A sine B equals a half into sine A plus B minus sine A minus B, close bracket. Now, A is 2 theta, B is 4 theta. So, cos 2 theta sine 4 theta ends up to be a half into sine. Now, A plus B is 6 theta. A minus B is minus 2 theta. Okay, so it's going to be sine A plus B, which is sine A plus B, which is going to be 6 theta. And then it's going to be minus sine minus 2 theta. Now, next thing you're going to have to look up is what's minus sine minus 2 theta. Okay? So, when you go to your notes, what you're going to notice here is in this corner here, it tells you about negative angles. Okay? And what it says about negative angles is that if you have the sine of a minus angle, which is located here, the sine of a negative angle equals minus sine of that angle. So, for example, sine minus 30 equals minus sine 30. Okay? The only thing that doesn't work that way is cos, because cos of minus 30 would equal cos 30. You can use your calculator to check this out if you want. So what does that mean regards our proof? Okay, so what does this mean regarding our proof? Okay, So what we can have here is that this here is going to be minus bracket minus sine 2 theta, using that rule there. And the two minuses make a plus. So it's going to be a half sine 6 theta plus sine 2 theta. Okay? And that is the integral. That is part 1 done. Expressed as the sum of two trigonometric functions. So do is I can get rid of this here and leave it as what I have down here. Now, once I've done that, what I'm asked to do next is hence evaluate this. So I'm going to change pi over 6 and 0 are going to stay the same. And I'm just going to substitute this in here. So that's going to be, instead of the cos 2 theta sine 4 theta, that's gone there. Then what you're allowed to do with integrals is, write the integral of 5x. Technically speaking, I'm allowed to bring the 5 outside. Okay? So if I was to do the integral of, let's say, 5x squared, the integral of 5x squared would be x cubed, and then the 5 would be divided by 3. Okay? However, if I did the integral of x cubed on its own with 5 outside, the integral of x cubed, the integral of, just give me a second there, oh, it's 5x squared is what I'm doing. The integral of x squared with the 5 outside is, I integrate that, I get x cubed divided by 3, and then I multiply it by the 5 on the outside, and you get the same answer either way. So what I'm suggesting we do with this function here is that you're allowed to take out the constant. No equal sign here. So we're going to move out the half. So we're going to get half bracket pi over 6 and 0 sine, and it's a d theta at the back, so sine 6 theta plus sine 2 theta d theta. Okay. So now we're going back to page 24 of our, 26. The integral of sine x is minus cos x. So what we're going to have is the half on the outside, and then inside here what we're going to have is this changes to what we're saying it was, changes to minus cos x. Okay, so it's going to be minus cos 6 theta. Remember to differentiate the angle and divide by it, all over 6 minus cos 2 theta, differentiate the angle and divide by it over 2, and then you have pi over 6 to 0. Okay, so what we're going to do next is we're going to ignore the half on the outside for a few minutes. So this half on the outside is just going to hover there on its own for a minute, and then we're going to do the limits on the inside in this green box here. So cos 6 theta is going to be 6 times pi over 6, which is going to be pi. 2 theta is going to be 2 times pi over 6, which is the same thing as pi over 3. Now that we've sorted that out, so one of them's going to be, the 6 theta is going to be pi, the 2 theta is going to be pi over 3. So what we're going to have here is it's going to be minus cos pi over 6 minus cos pi over 3 over 2. Then we have the minus brackets. That's this time it's going to be 0, so the 6 theta is going to be 6 times 0, which is minus cos 0 over 6. And then 2 times theta is 2 times 0, which is minus cos 0 over 2. What we're going to do next is put that into our calculator. We can use radians if you want. Just go to your setup, make sure you're in radians, which is number 4. Okay, let's see what we get here. So we're going to get minus cos pi, and we get 1, so that's going to be 1 over 6 minus cos pi over 3 minus cos pi over 3. Remember to divide it by 2 as well. minus a quarter. The half is still on the outside. Minus bracket cos 0. So cos 0 is 1. So that's going to be minus 1 over 6. And then cos 0 is 1 minus a half. All in brackets. Now what you're going to do after that is you're going to add the fractions up. So it's going to be a 6 plus another sixth. Or you can just do it all in one go in the calculator, I suppose. 1 over 6 minus 1 over 4 minus bracket 1 over 6 and then it's going to be minus a half 1 over 2 close bracket. You get 7 over 12. 7 over 12 and the half on the outside gives me 7 over 24. Okay, so 7 over 24 for that. Now, next one. Sketch the curve of this in the domain 0 to 4. Find the maximum value of y. So I'm just going to put that into my calculator. And what we're going to get here is mode table for alpha x minus bracket x squared 0 to 4 step of 1 0 0 1 3 2 4 0 0 1 3 2 4. Okay, after that we get 3 3 4 0 3 3 4 0. Next we're going to draw that out. Here we go there. So once we draw this out, we got 1 2 3 4 2 3 4, and then it has to go as far up as 4 on the other one, so it's going to be 1 2 3 and 4 0 0 1 3 2 4 3 3 4 0. And we have a typical n-shaped function with a maximum at 2 4, like so. Now write down the maximum value of y. The maximum value of y is 4. Primary graph, write down the minimum value of y in the given domain. The minimum value of y in the given domain is 0, because there's a 4 0 and a 0 0. Both have a y value of 0. Calculate the average value of y in the interval 0 to 4. So the average value of y is a function, so it's the average value of f of x, okay? So the average value of y is in the interval is given to you by this formula here, so we're just going to have to try and use this formula here. Okay, so what we have is over the interval. So the interval is 1 minus, so the upper interval minus the lower interval, so it's going to be 0 to 4, so that's going to be 1 over 4 minus 0, the integral of 4 to 0, f of x dx. What is f of x? Is basically y dx. So what is y? 4x minus x squared dx. Integrate. So it's going to be a quarter. Then what we have here is integrate this. It's going to be x squared. Divide the 4 by the new power, so it's going to be 2x squared. There's a minus 1x squared there. The new power is x3. Divide the old coefficient by 3, so minus 1 over 3. And that's from 4 to 0. Then what we're going to do next is it's going to be a quarter of 2 times 4 squared minus 1/3 4 cubed. And then the second one's just going to be 0 because there's x's in both of them, which means that 0 is going to be substituted in twice, which means it doesn't count. Okay, so then it's going to be a quarter of 32 minus 64 over 3. Put that into your calculator. A quarter of 32 minus 64 over 3. Close your bracket. And what you get is 8 over 3. So our answer there is 8 over 3. Verify that the average value of y lies between the minimum and maximum values. Does it lie between the minimum and maximum values of y? So y max is 4, y min is 0. So, and average is equal to, what did we say it was? Is equal to 8 over 3, which is 2.67. So we can see that our average value just does lie in between 0 and 4. Average value is 6.27, which lies in between 0 to 4. Very good. Now, moving on to the next part. The hemispherical ball of radius 6 centimeters contains water to a depth of 8 centimeters. Okay, so we're talking about a hemisphere here. So we're just going to do that. And then we're just going to have an ellipse, like so. And there is our hemisphere. Okay, maybe just a bit more tip on it. Hemispherical ball. Okay, the volume of the water. Volume is given by a third pi h squared 18 minus h. What I'm going to do is I'm just going to multiply this out, and what I'm going to get is a third. A third by 18 is 6, so it's going to be 6 pi h squared. And then multiply a third pi h squared by minus h is going to give me a third pi h cubed. Now, the volume of water is a third pi h squared multiplied. Water is poured into the ball at the rate of 18 centimeters per second. Okay, so water is poured. That's a volume change. So dV dt ends up to be 4. Find the rate at which the water level is rising. We want to find out what the h dt is when the depth is 2. So h equals 2. There's our accumulated information, okay? So what we can say is that dV dt ends up to be dV dH multiplied by dH dt. Now dV dH is this here. We got to differentiate it. Differentiate h squared, we get 2h. 2h multiplied by 6 pi is 12 pi h. Differentiate h cubed, we get 3h squared. 3h squared multiplied by a third minus a third pi. The 3's cancel, and you get minus pi h cubed, h squared I mean. We're told that h equals 2, so it's going to be 24 pi because we're replacing all h's with 2's. And that's going to be 2 there, so minus 4 pi because pi times 2 squared. And then we get 20 pi. So now we know that dV dt, which is 4 equals 20 pi times the h dt. The h dt ends up to be 4 divided by 20 pi. 4 divided by 20 pi is 1 over 5 pi. Or what's it? We'll just do 4 over 20 pi, might just make sense here. Okay, equal 0.064, let's call it. Same thing as 0.064. Now, remember, height is changing with time, so it's going to be centimeters per second. And that is the test completed.